Properties of ionic compounds. Properties of ionic compounds. Properties of ionic compounds. Generally, ionic compounds are excellent crystals. So that is the reason why they have an appropriate structure like BCC, body center cubic, phase center cubic, HCP, hexagonal close packed, CCB. So such type of structures are there for crystals or metallic crystals. For example, is sodium chloride. Sodium chloride is which type of structure? FCC structure. Its coordination number is 6. Coordination number means total number of ions surrounded by opposite ions in a ionic crystal is known as coordination number. In ionic crystals, around a central ion, the number of oppositely ions are surrounded is known as coordination number. In FCC structure, around Na plus ion, 6 chloride ions are surrounded. As same way, around Cl minus ion, 6 chloride ions are what happened? Surrounded, as well as around a Cl minus 6 Na plus ions, around a Na plus ion 6 Cl minus, around Cl minus 6 Na plus ions are surrounded. So that is the reason why the coordination number is how much? 6 only. Just around Na plus ion 6 Cl minus ions are surrounded. As same way, around Cl minus ion 6 Na plus ions are surrounded. This particular number is known as what? Coordination number. So the coordination number is 6. Now it has 8 corners. It is a cube, contains how many corners? 8. 1, 2, 3, 4, 5, 6, 7, 8. So that is the reason why 8 corners, each corner occupied by which one? A chlorine. So therefore 8 corner occupied by chlorine atoms, its coordination number equals to 8 into 1 by 8, that is equals to 1. How many phases? 6 phases. This is one phase, second phase, third phase, fourth phase. Okay, this is fifth phase. Now this is sixth phase. It is phase, it is also phase. So therefore total how many phases? 6 phases in this 6 phases center. So its coordination number equals to 6 into 1 by 2, that is 3. So how many edges? 12 edges in this particular cube. So therefore center Na plus ions equals to its coordination number equals to 12 into 1 by 3, that is 4. Okay, so how many body center? Only one body center in this particular cube. So its coordination number equals to what? That is 1 into 1, that is 1. So therefore now radius this is chloride ion. It is also a chloride ion. This is the center point. It is also center point. Between these, so which is occupied, this is occupied by which one? This is the half of the distance. So this is the radius of which one? Cl minus. It is also which one? Radius of Cl minus. Then this particular point is known as what? Radius of cation. What is that? Radius of cation. So this particular distance is known as bond length or edge length. This particular distance is known as what? Edge length. So therefore edge length equals to that is represented by A. Edge length equals to 2 into radius of Na plus radius of which one? Cl minus. Radius of which one? Cl minus. So by using this particular principle for FCC crystal which is calculated, edge length is calculated. Okay, effective number of ions equals to effective number of ions equals around Na plus ion 4 Na plus ions equals to 4, as well as Cl minus ions equals to, here is what? 4. Okay, so therefore 4 pairs. How many pairs? 4 pairs of Na sodium chloride. So 1 mole of crystal. What is that? 1 mole of crystal. 1 mole of crystal. 1 mole of sodium chloride crystal contains number of effective ions or number of pairs of sodium chloride in this particular into formula weight. Which weight? Formula weight. So 1 mole of ionic crystal. Okay, so in a unit cell, okay na, 1 mole of sodium chloride unit cell, 1 mole of crystal, that is unit cell. This is what? Unit cell contains number of pairs of sodium chloride into formula weight, that equals to 4 into formula weight of sodium chloride is 58.5. So therefore this value is approximately, it is which one? 4 5 here is 0 2 32 plus 4, it equals to 4 3, then 234. I think this is what? 234. What is the value? 234.0. So this about the grams. What is this? Grams. Okay na? So this about which crystal? Sodium chloride crystal.